All right, fine. So you're happy that you can get any of these coefficients just by thinking about the rows in the triangle, all right? However, what happens if we wanted to find the 100th row? Are we going to sit there and write out 100 rows of this triangle? No, I don't think so. We need a quicker way of doing this. We need a much quicker way of doing this. So the way which this can work is by thinking about it in terms of combinatorics. Yeah, combinations. We've already looked at this when we did our statistics. Okay, so do you remember this stuff? If I wrote down NCR, what would that correspond to? Like, what would that be equal to? NCR. Let me write it over here. What would NCR be equal to? Can anybody remember the formula? Of course, another way of writing it is like this. Can anybody remember what that's equal to, what the formula is? It's a fraction, okay? N factorial. Yeah, good. N minus R factorial. Good news, that formula is on the formula sheet. Okay. Okay, so don't need to remember it. And there's also, you've got your calculator as well. You're all happy with how you use it on your calculator? Yeah, good. So yeah, this is what this is equal to. Now, can anybody remember, what does this mean, like NCR? When we looked at it in terms of permutations and combinations, like ordering and arranging objects, what does this actually mean? What is this able to work out? So when would you use that particular formula? Good, exactly. So you're basically starting off with n objects, and you're just simply selecting R. This is how many ways you can select. Yep. So it's a number of ways of selecting R objects from a collection of n objects. Okay. So you remember this, like selecting R objects from a collection of n. Okay. Well, the question is, well, what on earth has this got to do with this? Okay, what on earth has this got to do with this? Well, let's have a think. Sorry? Yeah, it's this thing here. These are the coefficients, all right? The way which you can think about this, if you like, in terms of this triangle, is that there are 5 different ways to get from here down to here, okay? There are 10 different ways to get from here down to here. Okay, so there's like different paths which you're getting down there. So if you're like, you're selecting R roots from a selection of n rows. Is that okay? Yeah. I'll maybe show you a little bit more information, a bit more intuition about why it should be the case, why that row should correspond to this thing. But for the moment, just take it on my word that it is the same, just for the sake of time. Okay, so if we have time next week, I'll show it to you. All right, okay, fine. So what this basically means is that I now don't need to bother writing out this triangle, like as many rows I need in this triangle. I can just simply think of it in terms of my permutations and combinations, specifically my combinations. So for example, this one here, this number here, this coefficient, should just be 1. And what that corresponds to is 5, choose 0. So I'll write it like that. I'm choosing no elements from a collection of 5, okay? This thing here would correspond to 5, choose 1. So I have 5 objects and I'm selecting 1 from them. Okay? This one here would be 5, choose 2. This one here would be 5, choose 3. This one here would be 5, choose 4. And then finally, this one here would be 5, choose 1. Sorry, 5, choose 5, which is just equal to 1. Okay? Because there's one way of choosing 5 objects from a selection of 5. Yeah? So you're happy, you can kind of see the pattern here. The 5 corresponds to the power. 5 corresponds to the power. And this corresponds to which element you're looking at. Okay? So we've moved none across, 1 across, 2 across, 3 across, 4 across, 5 across. If you like, it's the column. It's the column. Is that okay? Yeah? So if I wanted to generalize this then, if we wanted to come up with a generalized formula, so if I take a plus b and raise it to any power, how would I do this? What's my first coefficient? Good, it's whatever my power is, and I'm choosing none, okay? What's my power of A? Good. And what's my power of B? 0, so I'm not going to bother writing it, okay? What's my next term? What's my next coefficient? N choose 1, perfect. What's my power of A? And what's my power of B? Yeah, it's just b, do b to the power 1. Okay, let's just do one more. What's the next term? N choose 2. What's my power of a? And what's my power of b? B squared, perfect. And then I'll just carry on like this for as many terms as I need until eventually I'll just end up with b to the power of n on the end there. Okay? Is that all right? So effectively, this is like a generalized formula. You kind of get the pattern though, yeah? I always say don't remember the formula with this kind of thing because it looks big and scary. Like, think about what we're doing up there. It's just simply the pattern.